the video solution of XM2. It's a prototype. Well, in XM2 prototype, I ask you to build an entire smart contract. In the real exams, I will ask you a shorter exercise, at least for academic year 2018-2019. So probably I ask you to modify an existing smart contract or to set up an even shorter smart contract. Okay. For this exercise, I take for granted that you have already experience with XM01. So, in fact, the student had received the text of XM01 before, so they had already experience with the other contract. This is the reason why this seems a little more complex, because you had the possibility to look not at the solution, but at least at the text of XM01. As usual, it's worth investing your time reading what I write, because I would like you to do what I write and not just take another contract, copy it, and hope for the best. So, the smart contract handles proposals and marriages. Please look at the plural, proposals and marriages. Okay, I'm not talking about only the marriage between Alice and Bob, which I'm writing here. I'm talking about generic proposals and marriages. Even though if you just make a smart contract which handles only one proposal and one marriage, okay, that's fine. It may work. It's much better than doing nothing, or much better than doing something wrong. Okay, I will take it into consideration, but my idea was proposals and marriages. Okay, the contract owner is the office which celebrates the marriage, so it's an external person. It's neither the husband, not the bride, especially because it handles proposals and marriages, so there are many husbands and many brides. When Alice would like to marry Bob, she makes a proposal indicating Bob's address, okay, and sends at least 1,000 way to the contract. This thing here implies that there is a function which we call proposal, for example, okay, in which a person must spend 1,000 way, okay, and indicate another address that he would like to marry. Okay. This proposal can be made only if Alice is not married and Bob is not married. So I imagine there is a data structure which tells us whether a person is married or not. And in fact, here I give you a suggestion. To check whether a person is not married, you check whether her spouse is the null Ethereum address. Okay. So I take for granted here that there is a data structure which we can call, for example, married, okay, which connects an address to another address. Okay, the address of the person with the address of the person to whom the original person is married. Okay. Bob may reject it and this sends the money back to Alice. So I imagine there is a function which is called reject, which only Bob may call, so only somebody who has received a proposal may call, okay, not anybody, and which sends the money back to Alice, okay. Otherwise, Bob may accept it. There is another function which is called accept, or the same function with as a boolean, but usually making another function is easier, and paying 1,000 way to the contract. Okay, in this case, they are married. Okay, so you must write in your data structure that Bob is married with, that Alice's husband is Bob, and that Bob's wife is Alice. And the 2,000 way they have paid are transferred to the contract owner. Pay attention that even though here we're talking about money, well, you could have a balance structure, but is it really necessary? Well, if they reject, the 1,000 way are sent back. If they accept, everything is sent to the owner of the contract. So, okay, let's see the suggestion. Here, I'm basically suggesting you that there be a data structure which tells who is married with whom. Okay, so which connects an address with another address. Okay, and here I suggest you that there is a second data structure, and this is the same data structure, more or less, that exists in the previous exam, which connects a plate with an address. This I suggest another data structure, Okay, you can use another mapping with the proposer as a key and the recipient as a value. So another data structure which connects who has received a proposal, who has made a proposal with who has received the proposal. Okay. Okay, pay attention, blah blah blah. Okay, let's try to set up some data structures. Here, new Mary. Okay. Pragma Solidity 0.5. Okay, contract. Okay, so I will build a compiler. Okay, at least larger or equal. Okay, I am as usual in autocompile, so I will see immediately the errors. Okay, so mapping address, where is the equal? Here, equal with address. Married. It's public. Well, usually marriages are public. Okay. So this data structure will tell you that this person is married with this one. Okay. Pay attention that you must also put that this person is married with the other one, but okay, we'll take care. As it's written in the suggestion, have another data structure which is the same. Let's make it public. In a real application you can make it private. Proposed. I don't want to call it proposal because I will call the function proposal. Proposed. A key made a proposal to value. So the key, which is this person here, made a proposal to this one. Okay. So if proposed of Paolo is set equal to whoever, I don't want to say any name to avoid, okay, it means that Paolo made a proposal to whoever. So if I made proposed, for example, now suppose this is my address, okay, it's equal to, this is another address. Okay, it means that I made a proposal to this person here. Okay. Okay. Here instead doesn't matter because the marriage is he is married with value, but you will automatically have to insert also the fact that the reverse. Okay. Okay. So we have this data structure. We need also the address. It's payable, public, celebrator. Let's call it celebrator. It's the person who celebrates the marriage. It's the owner of the contract, the one which will receive the 2000 way in case the marriage goes well. Okay, so if you instead misunderstand my request and makes a contract for one proposal only, well, in this case you will have to have a data structure such as Bob or husband, okay, as an address, Alice or wife as another address, and then you will have to keep track of the status. Okay, it will look more like a contract than like it will look like a purchase contract. We will try to do it later on. Well, this was the standard solution. So function proposal. Okay. No, first the constructor. Okay, public. Okay, simply celebrator equal msg.send. We set who can celebrate, nothing else. Function proposal. The person who makes it is the. Oops, there is a problem here. What's the matter? Expected identifier, but got constructor, not constructor. Okay. Okay. Function proposal, sorry. Public. Okay. Proposal must indicate an address. So address. Suppose. Or person. Okay. So the person who makes the proposal. So the message sender is the one who makes the proposal, and this one is the person which receives the proposal. So first we must check that exactly 1000 way, or at least, let's see. At least. At least 1000 way are paid. Okay. What's the matter here? Message value. It's not payable, so oops. Payable. Oh. What's the matter? Wait, I have to finish it. Okay. Now, okay, we must set proposed. Okay, the sender. Remember, the key is the person who made the proposal. Okay. Now, if you want to be serious, wait. You have to check first that this person is not married. And that also this person is not married. Because if you're married, we are a serious organization. If you're married, you can't make marriage proposal. Okay, first get divorced. So, require msg.sender must not be married. So, married msg.sender equal the null address. Let's do like this. When the autocompile will stop with error, it's over. Will the autocompile stop with error? I think we put too many. Okay, let's count them. Okay, these are 10. I copy them. Okay. The Mac. Ctrl C, Ctrl V. Okay, 40. Okay. So we require that the person who made the proposal is not married. And we require also that the person which receives the proposal is not married. Okay. You could also require that the person who made the proposal is different from the person who receives the proposal. This is not necessary, honestly, if somebody wants to marry himself. But let's just do it. You will get extra point. Send equal different. Okay. So nobody can marry. Nobody can make proposals to himself. Okay. Okay. That's it. Okay. Now the function accept, or the function reject, which is easier. Reject. Okay. Well, just reject public. Okay. The function reject may be called only by somebody who received a proposal. So require. It means that you received a proposal. So it requires that. No, wait. Let's see here the instructions, because the proposer has key and the recipient has value. No, there is a mistake here in the suggestion. The recipient has key and the proposer as value. Okay, sorry, there was a mistake in the text. So it's exactly the vice versa. So value made a proposal. This is for technical reasons. Okay, so in this case it's proposal of person. This is who receives the proposal. Okay, so because now it's easy, we require that proposed of message sender be different from the null address. Okay, so we require that you actually do have a proposal. Okay, you must have a proposal. In this case, what happens? So, first of all, you don't you send the money back. So, but to whom? Well, you send the money back to the person who made the proposal. So, okay, to the person who would like to be your boy or girlfriend. Transfer. Okay, we transfer 1,000 away. Well, if this person has given us more, too bad for him. Okay, and then we delete the fact that we received a proposal. Okay, so we set proposed message sender to nothing. This is the address of the person who made the proposal. So we transfer him 1,000 away, and then we delete. So now message sender is free. Okay, let's write here. Okay. Well, in theory, you should check also here that not only message sender is not married, but also that message sender has not received another proposal. Otherwise, it will overwrite all proposal. Well, depending on what you want. Here maybe, what's the problem? A proposed message sender must be payable. So, because we must return the money. Okay. For him. Okay. So in theory here, if a person has already received a proposal and somebody else makes another proposal, it will overwrite the previous proposal. This is probably what happens in real life, so let's keep it. Okay, reject, and now function accept public. Okay, again, you must have received a proposal from somebody. Okay. In this case, what happens? It's also payable because you must pay. Let's see. Okay, it's also payable. Okay. In this case, what happens? Well, first of all, you send 2,000 away to the person who celebrates a marriage. So, celebrator.transfer 2,000. Okay. So first get the money. Then mark the two people as married. So, married. So we mark message sender as married with the person who made the person who made the proposal, which is this one. Okay, and we mark the person who made the proposal married with message sender. Okay. So this is to mark message sender, so the person who accepts the proposal, married with the person who made the proposal. And this will mark the person who made the proposal, this one, married with message sender. I think we have done everything. Yes, seems everything. So the only upgrade, if you want, is to check here that the person should not have received other proposal before, but you can delete the proposal once that you are married. You never know. Let's delete the proposal. So we forget who made the proposal. Okay, once they're married, we don't need the proposal anymore. We delete it. This is optional, however. Let's comment it out. Okay. Okay, I think we are. Oh, there's a mistake. What's the matter here? Oh, it's buyable public. No. What's the matter? Ah, no, sorry. It's a payable address here. No. Ah. Okay. It's address payable. Okay. I think we have all the tools. It's rather short as a content. The complex thing was to having clearly in mind the data structure. Okay, then I will make another content in which we, as a mistake, we assume that you have to marry only 2 people. Okay, let's see. I now deploy it on the blockchain. I am pretty sure that it works. Compile, deploy. Let's see. I open my secret password. So I switch to account 1. I deploy it. Deploy. Invalid form address. Ah, sorry. When I deploy, I have to specify something. No. Deploy celebrator message sender. Inject web3. The address is this one. Let's see. Recompile it just to be sure. Deploy. Okay. Let's wait for the confirmation. What are the miners doing? Oh, come on, miners. Okay, mind. Okay, I copy the contact address. I put it here because I want to check what's happening on this contact. Okay, currently only created. Okay, let's see. Make it larger. Okay. Now, first of all, I will make a proposal. Well, let's better change it. So account 2 will make a proposal for account 3. So first I have to get the address of account 3. I copy the address, switch to account 2. Now account 2, which is rich, makes a proposal for account 3. Proposal. Okay, transact. Confirm. Okay. In the meantime, let's check the celebrator. Okay. Let's check whether account 3 is married. No. Let's check whether account 3 has received a proposal. Currently no, but probably because there is time. Okay. You see, account 3 has received a proposal from account 2. Let's see what's happening here. There's another transaction. Okay, from account 2 to the contract. It pays 1000 Ether. If you want to check the transaction, you can see here there is hidden the address of account 3. Okay. Now, account 3 should accept it. Okay, account 3. Accept. Gas estimation will likely fail. Wait. Ah, yes, you have to pay 1000 UA. Okay. Confirm. And the celebrator will get 2000 UA. Okay, mined. Let's see what's on the blockchain. Still to go. When it's mined, it means that it's on the blockchain of the miner. It waits a little bit before it arrives on the blockchain, also on this computer. So it's because I remind you that the blockchain is a peer-to-peer network. Okay, so, okay. Okay, it's another account which, okay, confirms, sends one either. Unfortunately, here you cannot see that the contact itself sends now 2000 way to the first address, but that's it. Can you see? Oh, still proposed. Ah, yes, because we commented this one, so it's still marked as proposed. Now it's marked as married. So 0 by D4, it's married to 0 by 7 2, and 0 by 7 2 is married to the other one, I hope. Yes. Okay. You can try as an exercise to make the function to divorce. You can see whether making the function to ask for divorce or to directly divorce without the consent of the other person. Okay, that's it. And yes, let's build now another smart contract. Suppose that you misunderstand and you want to build a smart contract which only celebrates the marriage between two people. Let's call them Alice and Bob. Alice and Bob are not chosen because of any particular persons, but because they're the typical two people involved in any cryptographic example. Okay, so single marriage. Okay. Pragma Solidity. It is not the way it should have been solved, but if you solve it in this way and you do everything right, I will strongly appreciate. Okay, contract 1 marriage. Okay, so here which data structure? LZ Bob, it's an address payable because it will have to receive the money back in case. Address payable Alice the ones who make the proposal, Bob is the ones who receives the proposal. Actually Bob doesn't need to be payable because he receives the proposal, so doesn't get money back. Address still the celebrator, it's an address payable address. I don't know, remember whether we need something else. Maybe a status variable, so enum status type. It can be start, comma, proposed, comma, married. A constructor public a celebrator equal msg.sender. Okay, fine. Now a function proposal. Alice must indicate Bob's address, so address B, public, payable because Alice will have to pay, require msg.value larger or equal to 1000. Okay, let's put also another requirement, so msg.sender cannot be not to interruption, the Mac suddenly crashed. Okay, let's go on. Okay, so message. Okay, this is just to check that it's not Bob who is trying to marry himself. Okay, so now Alice equal SB. Oh, IB. So, no, it's Bob, sorry. No, so Alice. It's not Alice who is trying to marry herself. Bob equal B. Okay, so we put the address of Bob there. Now the function for Bob to accept. Oh, we should put here the status equal as proposed. Okay, here we should set the status equal start, and we'd better here require status equal start. Status type dot start here. Status type dot. Okay, and here status type dot proposed. Okay, function reject public not payable because there is nothing to pay when it's reject. It only Bob can reject. The message sender must be Bob. The status must be proposed. Otherwise, there is nothing to reject. Otherwise, okay. Sorry, here semicolon. I'm not looking at the autocompile anymore. Okay. There's a mistake here. Enum status type equal. I don't remember. Let's see. Okay, there is a space. Does it go? No. Why here does it work? Enum status type. Okay, what's the matter? What's the matter? Expected dot. Was it? Maybe it doesn't require the semicolon at the end. Even worse. This is the other counter, no? Okay, let's copy it. Ctrl C. Ctrl V. Status type is right here. Start. Proposed. Married. Okay. What's the matter now? Yes, I have to set, obviously, a status type public status. Okay, I have to set variable status. Okay. So the status must be proposed. The sender is Bob. So first of all, we give the money back to Alice. So Alice dot transfer 1,000, even if she paid more, worse for her. Well, in this case, we can send back the entire balance because it's a contract for one single proposal. And we set the status as start. Okay. Now the function accept, I copy it because it will be similar. Accept. This must be payable. Okay. Only Bob can accept. The status must be proposed and Bob must pay at least 1,000 Wei. Okay. In this case, transfer everything to the celebrator. 2,000. Okay, the status is married. Can you see here it's very different because being a single contract between two people, the status, the fact that they're married is indicated only by a status variable. Okay, if you want, you can set up a similar structure with a mapping address married public. Okay, and indicate here that married Bob is equal to Alice and married Alice is equal to Bob. It's pretty useless because this is a contract only between Bob and Alice. Their names are clearly, their addresses are clearly visible in Bob and Alice. So this is pretty useless. So if you made a contract for only one marriage, you don't need this data structure. Okay, now the contract works fine. I try it just on JavaScript virtual machine. I deploy it. Okay, it's here. Status 0. Let's switch to account 2. So I deployed it with account 3. So account 3 is a celebrator. Account 2 will be Bob. So I copy the address. I switch to account 1, which is Alice. So now Alice makes a proposal to Bob. No, not valid. I have to put it here. It's very annoying that you have to put every time here. Transact. Why? I have to send 1,000 away. That's why. Okay, done. Now status is 1. Okay, we don't see who is Alice and who is Bob. Because I didn't specify anything, so they are private automatically. Okay, it isn't... Okay, being private means that... Let's put them public. Otherwise nobody knows that they are married. Okay, redeploy again. Deploy. Okay. I deployed it with address. Which one? 1. So now it will be account 3, which makes a proposal to account 2. So I go to account 3. Proposal. Currently Alice is empty and Bob is empty. I have to pay. Okay, done. Let's see. Now we know who are Bob and Alice. We know who are Bob. Oops, I forgot to specify who is Alice here. Alice is msg.send. Oops. Big mistake. Now, redeploy. This time I deployed it with account 3. So account 3 is the celebrator. I will go to account 1, who will make a proposal to account 2. So Alice is null. Okay. Celebrator is account 3. So send 1,000 away. Okay, that's the Alice is this address, Bob is this other. Okay, now I have to switch. Can you see now I try to reject, but with Alice. Doesn't work because only Bob can reject. Oops. I inserted here an account which is a real account, so now I can't reject anymore. Now it's stuck. Because I made a proposal to a link B account, but now I am on JavaScript virtual machine. I'm a disaster. Retry. Deploy. Okay. This one is the deployer. Let's switch to the third one. Copy the address. So the second one makes a proposal to the third one. Exact. To pay. Okay. So now we know who is Alice and who is Bob. I go to the third one. The third one accepts. No, must pay to accept. Okay, done. Okay. And now they are married. The status 2 married. Alice and Bob are still the same. Okay, fine, it works. Okay, so making a contract for the marriage of 2 people is as complex as making a contract like this one for the marriage of n people generically, so even shorter. Okay, that's it. Let's see whether I'm able to stop it. Goodbye.